Nilan is a Danish company, and it was founded back in the 70s by a gentleman called Torben Andersen, who's actually the inventor and and an engineer, and still actually is head of the company. Even to this day, he's in his 70s now. His vision, particularly back then, was to look at low energy buildings, and what he did was he took the primary energy, the function of exhaust air as an energy source, and his design was to capture that exhaust energy and produce your hot water from it. So that's waste heat, which otherwise would have been dumped out of the house, and at the same time develop heating and then cooling from the same source of energy. And I suppose what in turn what happens then is that you develop a good indoor air quality, which is important and very cost effective. And how Nilan Ireland was set up was that as low energy buildings came into play, and particularly when systems like KORE came into fruition, there was a demand for the types of technology that Nilan were developing. So that's why Nilan Ireland was created. So the Compact P was developed, it was actually developed in conjunction with the Passive House people. So effectively, if you broke down the Nilan unit, you had a hot water cylinder, you have a passive heat recovery, it's just a standard heat exchanger that you would have maybe with 2 fans. And then you have a heat pump. And then that heat pump then will heat the air because you won't heat a building with just a standard heat recovery system. And what about the hot water? So ideally, the unit was developed in the name being compact means that everything is in one big box. And so the exhaust air that's leaving the building, and it's leaving 24/7 and is leaving at 20 degrees plus. So that's valuable energy. And I tell people, whoever build very energy efficient buildings, make them airtight. Well, that's an energy source that you want to capture. And so what the unit does is it takes the exhaust air. If there is a demand for hot water, it uses heat pump technology to transfer that energy, and it can take it from 20 degrees and turn water into over 55 degrees, 60 and 70 and even higher. So that's the technology. And then if there's a demand for heating, it shares that energy between the water and increases the air. So if the air comes in at cold ambient temperatures, it will go through the first stage passive heat recovery. So that's a lift. That doesn't cost any money. And then the temperature then is taken up by the heat pump to over 30 degrees, 35 sort of degrees during the winter time. And it continues delivering warm air for as long as the building demands it. That about 6 years ago, we got involved in a project which actually an architect had actually specified KORE. So really it was our first introduction, and we were obviously fascinated by it. And once we come to terms with the way they build up the system, we could easily see then that the KORE system would easily accommodate our ventilation system, our supply air, and our underfloor heating system, because obviously Nilan supply air at floor level, and once you can accommodate the ducting in your floor, it makes a lot more sense for us, and it's much quicker to install. We both have a concept of delivering cost-effective solutions, and KORE being one and Nilan being the other. Well, particularly, we've done quite a few systems right now, and we've got very familiar with it. So the first and foremost is that we have to work with the contractors that are installing the system, so we know what stage they're at, whether it's the external perimeter ring beam, and then followed by the first. So we go into the middle layer typically of that. So we're pretty much integrated part of the design. But once we have a clean slate to work with, we can easily get our ducting system down into the insulation. It's sandwiched in with the second layer, and then the third layer goes over the top, and therefore our ventilation system is capsulated in the insulation, and it almost forms an insulator for the supply air. What we found is that in the traditional system is that you just have no idea what the level of thickness is going to be. and it varies from site to site. And in that case, then we try to work with the contractor, which means that we try to say we need a layer of insulation that would accommodate our pipework, which is one thing. And then the other thing is that then when we get to site, we're trying to find out whether the insulation is put down. And in some cases, you're trying to find out who's responsible for laying the insulation. So there is inevitably long delays because it's generally done by the contractor or by one of his people on site. So you're never 100% sure on the delivery of timescales for doing it. The compact P that went in there is like, for example, is like a big American fridge. Hot water cylinders built in there, the passive heat recovery is in there, and there's a small heat pump that takes the energy, produces hot water, and then heats up the supply air and cools it in the summer. But the point is that the site was built on the basis of not having a wet heating system, which means effectively there's no radiators, there's no underfloor heating, and it's compact design, which meant is that the contractor could save money by putting more money into the insulation of the building and taking a fabric first approach. And of course, with the KORE system, it speeded up the process. And the feedback that I've got from the contractors anyway is that using KORE system allowed them to have less materials being moved from site. And that's a big cost saving because it has to be dumped somewhere and there's a cost associated with that, which meant then that the KORE system went in, and then we came in later on in the build to put the insulation in. So to me, it was pretty seamless, really. Well, again, I put down to a contractor, particularly is that the wastage on site, the digging out of a strip foundation, the removal of earth is a big thing because there's a big cost associated with that. But from our perspective, using the KORE system would limit thermal bridging. And when you limit thermal bridging, you limit the amount of heat loss. Essentially, the footprint of the building isn't a big heat sink. And if we get that right, that means that the type of systems like the compact P, heating through supply air, the energy demand is so low that it makes these types of systems more effective to use. And therefore, the contractors have less plumbers and wet trades coming into the building, and that speeds up the whole process. So there's a win-win on both sides. Well, I suppose you could start with the sciencey bit. Everyone wants to build the best that they can and make it really cost effective and comfortable. And all I can say is that it's always been a bugbear for ourselves with strip foundations. We try to get the contractors to use thermally light type blocks to break thermal bridging, perimeter insulation, and it really does come down then to the application on site. That's the big thing. So you've got this big, massive footprint sitting on the ground, and it literally wants to soak the heat out of the building. That's what it wants to do. I think the KORE, well, definitely the KORE system, I describe it the biscuit tin with insulation. So it's a biscuit tin made of insulation, and you pour concrete into it. That's what you sit. That's what's there. So the bridge is breaking. So I said, if you start at that basis, that eliminates all the losses into the ground, and then from then up is what you can see. It's what you can't see is directly below you, and you can't go back and decide to retrofit insulation into a foundation. It just doesn't happen. You have to do that side well and from the very beginning. So if you're going to compromise on costs, do it somewhere else, but definitely not on the foundation.